The Master Production Schedule (MPS) serves as a primary operational plan that translates business objectives and aggregate plans into specific production commitments. The master schedule process flow begins with inputs from sales and operations planning (S&OP), demand management, customer orders, forecasts, inventory records, and capacity considerations. These inputs are consolidated into a detailed production schedule that specifies what products will be produced, in what quantities, and when they will be available. The MPS then drives material requirement planning, procurement activities, capacity planning, and shop floor execution. Because it connects strategic plans with operational activities, the master schedule acts as a critical communication tool that aligns multiple business functions and supports coordinated decision-making throughout the organization. Maintaining the MPS requires continuous monitoring and adjustment as business conditions change. Master schedulers must coordinate modifications resulting from changes in inventory levels, customer orders, backlog, available capacity, supplier performance, product designs, process improvements, and demand forecasts. Every adjustment must be evaluated carefully because changes in one area often affect multiple functions throughout the supply chain. Effective schedule maintenance balances responsiveness with stability, ensuring that customer requirements are addressed without creating excessive disruption. The objective is to preserve schedule integrity while accommodating necessary adjustments. Successful maintenance depends on timely communication, disciplined change management, and cross-functional collaboration among operations, procurement, sales, engineering, and supply chain teams. A fundamental tool used in master schedule management is the concept of time fences. Time fences divide the planning horizon into zones that control the degree of schedule flexibility. The frozen zone represents the near-term period where changes are highly restricted because materials have been ordered, production activities have begun, and commitments have been made. The slushy zone permits limited adjustments, subject to management approval and resource availability. The liquid zone, located furthest into the future, allows greater flexibility because fewer commitments exist. Time fences help balance schedule stability and responsiveness by preventing excessive changes that can disrupt operations, increase costs, create material shortages, and negatively affect customer service performance. Projected Available Balance, PAB, is one of the most important calculations used in maintaining the master schedule. PAB measures the expected inventory available after satisfying forecasted demand and customer orders during each planning period. When time fences are not applied, projected inventory is calculated using forecast requirements. Within time fence boundaries, customer orders generally replace forecasts as the primary source of demand because actual orders provide more reliable information. Monitoring projected available balance enables schedulers to identify future shortages, excess inventory situations, and replenishment requirements before they occur. Maintaining appropriate inventory and backlog levels through PAB analysis helps organizations support customer service objectives while controlling inventory investment and operational costs. Master schedule performance must be measured continuously to ensure operational effectiveness and planning accuracy. Organizations use key performance indicators, KPIs, such as schedule adherence, forecast accuracy, customer service levels, on-time delivery performance, inventory turns, backlog management, and production stability to evaluate performance. Additional indicators may reveal underlying problems, including excessive schedule changes, recurring shortages, expediting activities, capacity overloads, or persistent inventory imbalances. Policies and controls establish acceptable performance standards and provide guidance for corrective action when deviations occur. Consistent performance measurement helps organizations identify weaknesses in planning processes and supports continuous improvement efforts that strengthen schedule reliability and execution effectiveness. Engineering changes present unique challenges for master schedule maintenance because modifications to products, components, or processes often affect inventory, procurement activities, production schedules, and customer commitments. Effective implementation requires evaluating engineering change timing, existing inventory levels, supplier commitments, work-in-process inventory, and customer requirements. Organizations must coordinate revision control, effectivity dates, and communication across affected departments to minimize disruption. Failure to manage engineering changes properly can lead to obsolete inventory, production delays, quality problems, and customer dissatisfaction. Master schedulers therefore play an important role in ensuring that engineering changes are integrated into production plans while preserving schedule stability and maintaining operational performance. Organizations must recognize the consequences of failing to follow the master schedule and understand when a schedule has become unrealistic. Frequent schedule changes, excessive expediting, recurring shortages, chronic capacity overloads, poor supplier performance, and declining customer service often indicate that the schedule is no longer achievable. Ignoring the MPS undermines planning effectiveness, increases operating costs, disrupts material flows, and reduces confidence in organizational plans. An unrealistic schedule may result from inaccurate forecasts, insufficient capacity, unreliable suppliers, excessive customization, or inadequate communication among functions. Continuous monitoring, timely corrective actions, and disciplined schedule management help maintain schedule credibility. By preserving the integrity of the MPS, organizations improve operational stability, support customer commitments, and enhance overall supply chain performance.